Another day, another story of the future. What is a blockchain? A blockchain is a distributed database or ledger that is shared among the nodes of a computer network. As a database, a blockchain stores information electronically in digital format. Blockchains are best known for their crucial role in cryptocurrency systems, such as Bitcoin, for maintaining a secure and decentralized record of transactions. The innovation with a blockchain is that it guarantees the fidelity and security of a record of data and generates trust without the need for a trusted third party. One key difference between a typical database and a blockchain is how the data is structured. A blockchain collects information together in groups, known as blocks, that hold sets of information. Blocks have certain storage capacities and, when filled, are closed and linked to the previously filled block, forming a chain of data known as the blockchain. All new information that follows that freshly added block is compiled into a newly formed block that will then also be added to the chain once filled. A database usually structures its data into tables, whereas a blockchain, as its name implies, structures its data into chunks, blocks, that are strung together. This data structure inherently makes an irreversible timeline of data when implemented in a decentralized nature. When a block is filled, it is set in stone and becomes a part of this timeline. Each block in the chain is given an exact timestamp when it is added to the chain. How does blockchain work? While underlying blockchain mechanisms are complex, we give a brief overview in the following steps. Blockchain software can automate most of these steps. Step 1. Record the transaction. A blockchain transaction shows the movement of physical or digital assets from one party to another in the blockchain network. It is recorded as a data block and can include details like these. Who was involved in the transaction? When did the transaction occur? How much of the asset was exchanged? How many preconditions were met during the transaction? Step 2. Gain consensus. Most participants on the distributed blockchain network must agree that the recorded transaction is valid. Depending on the type of network, rules of agreement can vary but are typically established at the start of the network. Step 3. Link the blocks. Once the participants have reached a consensus, transactions on the blockchain are written into blocks equivalent to the pages of a ledger book. Along with the transactions, a cryptographic hash is also appended to the new block. The hash acts as a chain that links the blocks together. If the contents of the block are intentionally or unintentionally modified, the hash value changes, providing a way to detect data tampering. Thus, the blocks and chains link securely, and you cannot edit them. Each additional block strengthens the verification of the previous block and therefore the entire blockchain. This is like stacking wooden blocks to make a tower. You can only stack blocks on top, and if you remove a block from the middle of the tower, the whole tower breaks. Step 4. Share the ledger. The system distributes the latest copy of the central ledger to all participants. How is data added to a blockchain? Beyond being transparent with data, the blockchain is also a secure way to store it. Using Bitcoin as an example, here's how a transaction is added to a new block. When a Bitcoin user sends a transaction, a message is created with both the sender's and the receiver's public addresses and the amount being transacted. The sender takes this data, adds their private key to the mix and then creates a hash of it, turns it into a fixed-length code. This creates a digital signature to confirm the person who owns the amount of Bitcoin intends to send it to the receiver. The sender then packages this digital signature with the message and their own public key and broadcasts it to the network. The packaged transaction joins a waiting room filled with other unconfirmed transactions looking to be added to the blockchain, known as a mempool. In the case of the Bitcoin network, miners who have successfully discovered new blocks through proof of work then take a batch of transactions from the mempool, usually based on which ones have the highest fees attached, verify each transaction to make sure each sender actually has the amount of Bitcoin in their wallets they want to send, run it through software to make sure the packaged data, digital signatures, messages, and public keys are legitimate, add it to the new block, and finally, broadcast the proposed new block to the network so that other miners can double-check everything is correct. This is similar to the process used in proof-of-stake blockchains, except instead of mining nodes discovering and verifying transactions, users who have locked away an amount of cryptocurrency, known as stackers or validators, carry out the process. Nodes can perform a variety of tasks. These include keeping a historical record of all transaction data, verifying transactions, and, in the case of mining nodes or validator nodes, adding new blocks to the blockchain. Once a transaction has been approved and added, the information cannot be altered or rewritten. That is why data stored on a blockchain network is described as immutable. The blockchain simply records every transaction that has ever taken place on its network. For example, the Ethereum blockchain is a record of all Ether transactions that have ever taken place. So if there are updates that need to be made around a previous transaction, rather than going back to the initial data, a new record is made about the change. Key elements of a blockchain are: distributed ledger technology. All network participants have access to the distributed ledger and its immutable record of transactions. With this shared ledger, transactions are recorded only once, eliminating the duplication of effort that's typical of traditional business networks. Immutable records. No participant can change or tamper with a transaction after it's been recorded to the shared ledger. If a transaction record includes an error, a new transaction must be added to reverse the error, and both transactions are then visible. Smart contracts. To speed transactions, a set of rules called a smart contract is stored on the blockchain and executed automatically. A smart contract can define conditions for corporate bond transfers, include terms for travel insurance to be paid, and much more. What is the difference between a database and a blockchain? Blockchain is a special type of database management system that has more features than a regular database. We describe some significant differences between a traditional database and a blockchain in the following list. Blockchains decentralize control without damaging trust in the existing data. This is not possible in other database systems. Companies involved in a transaction cannot share their entire database. But in blockchain networks, each company has its copy of the ledger, and the system automatically maintains consistency between the two ledgers. Although in most database systems you can edit or delete data, in blockchain you can only insert data. With many practical applications for the technology already being implemented and explored, blockchain is finally making a name for itself in no small part because of Bitcoin and cryptocurrency. As a buzzword on the tongue of every investor in the nation, blockchain stands to make business and government operations more accurate, efficient, secure, and cheap, with fewer middlemen. As we prepare to head into the third decade of blockchain, it's no longer a question of if legacy companies will catch on to the technology. It's a question of when. Today, we see a proliferation of NFTs and the tokenization of assets. The next decades will prove to be an important period of growth for blockchain. Thanks for watching. Subscribe for more technological trends and videos.